Hi there, my name is Anton, and today I want to discuss the major development in computer vision over the past year, which is the creation of many strong pre-trained models. And in my opinion, this is similar to when we moved from old algorithms where we should handcraft all features to neural networks, and it's bring more predictability and higher quality to the process. However, there are still some challenges to overcome. Let's look at few examples of good pre-trained models. First of all, it's DynaV2, segment anything model. And also there are a lot of models built on segment anything like Lightning SAM and so on. Clip. L3 it's pretty old model, but there are newest model based on Clip. And for example, you can look at OpenClip. Of course, it's like a set of good, big pre-trained models that achieve first place on a lot of challenges like UniNext, intern image, intern video, a lot of pre-trained detection models based on Swin, a lot of YOLOS models, and of course it's GPT-4V, which is one of the best image models nowadays, but with a lot of problems. Okay, let's take about the usage. And the first approach is pretty straightforward. Just use the model. Sometimes it's work well. If your data domain match your pre-trained domain, you're in luck. For example, if you're detecting like cars, boats, planes, everything will work. A lot of models usually trained on 80 classes from Coco. Some networks are trained on hundreds, some are using ability of integration of text embeddings and visual embeddings like ground and Dina. But of course, when your model see something new, for example, I don't know, something about building construction, it will not work because it's completely different domain from all internal collection data. And I saw a lot of such examples. For example, some metal welding, some medical tasks. You can't use existing pre-train and be sure that it will work. But pretty often when you class in pre-trained domain, everything will work. Also, it's almost the same for DynaV2, Clip, and other one-shot approaches that allows you to extract and compare features. They work well. But the more similar the things, the less variation, the worse they will work. These networks don't know anything about your task. If you have two identical pizzas, one of which is slightly burned, comparing to the closest will not allow you to distinguish which one is which. The only one network that's more or less stable is GPT 4V. But look, for example, at this post. The doctor tells his impression of the network's responses. And there are a lot of such problems. You don't know where you have exact answer and where GPT-4 start hallucinating. So you shouldn't use hard tasks. For example, the previous task with pizza also is pretty hard. But if you need like to recognize type of your car, definitely GPT-4 will work. The second approach is to train linear classifier. One of the best approach. Take the network output features and train simple single layer network or some classification like SVM classification. This solves a lot more problems, especially for the classification. For example, the above example with pizza works pretty well. But if your task lies outside of domain of training, or the object that you are looking on is super similar with small difference, it also may not work. Uh, Speaking about the different domain, for example, if you take action recognition network that works super well for humans, it may not work for animals, and so on. If you want to predict the months of pregnancy of a cat, it's like DynaV2 also may not build sufficient linear classifier, even if it's super easy to train the network that can predict this. The third approach is to use pretrained network as a backbone. And the good example is Lightning SAM. You take a large net and tune it a bit with your dataset. It's the same training as any other training, just with smaller dataset. What does it do? Because you can train a network faster, and it's the most important thing. You need less data, and the network is much faster converge. So you just need not a thousand of images, but hundreds. And what's the downside? It's just like training the regular neural network. And you need more hardware than you need, for example, to train UNet. Let's speak about the global disadvantages of all these pre-trained networks. The first of all, if you don't want to train, you are limited by the original models. And in case if it's GPT-4, you are okay, but for GPT-4 you need a lot of time for inference and a lot of money. But for all other models, the initial pre-train task will limit you. If you want to train something, be it a linear classifier or the network itself, you need to collect and balance your dataset, just with regular network. Of course, your dataset may be 10 times smaller, but you need to be sure that your dataset is representative. You need to be sure that all your classes is within this domain. And for example, if you're recognizing animals, you don't need like 100 of images of each new animal in your dataset. It will be enough to have like 3 or 4 images for each one of them if you train in like DynaV2. But if you're recognizing something like X-rays or some medicine data, you need much bigger dataset because all of these internal problems, they are super different, the same class. Even the human are not sure about which one of the problem here. So you need much bigger dataset. Of course, it can be like a few times smaller, but the same approach. And second minus is the speed. Usually the large pre-trained models are transformer, and they can't be used on edge or as real-time processing of video stream. So, of course, you can solve this. For example, you can distill your final model in the smaller one. But at the same time, you need much more work on this because it's not a stable process. You need pretty big and representative dataset for this distillation. Even if it will not be labeled, you need this dataset, you need to create it and structurize this. In my opinion, it's just this pre-trained networks is a cool instrument that can solve a lot of problem, especially in the situation when you have only small amount of data. It's super good for prototyping. It's super good to building some models that work super good. But it's not like solution for all your problem. Okay, that's all for this time. If you want, I can do the next video where I will speak more about different pre-trained models, like how you can work with Dynavit 2, how you can work with Clip, or any other. Thank you for watching. Bye.